Now at actually finding the zeros on a graph. And the term zeros really does refer to finding the x-intercepts. And the x-intercept is where the graph or the parabola or the line or whatever, where it actually crosses or intersects. Okay, so where it crosses the x-axis. Okay, and so when a line or a parabola or whatnot crosses the x-axis, that means that the y value of that particular point is actually equal to 0. Okay, so for example, in point 30 is on the x-axis. That is an example of an intercept. Okay, so here we have three different graphs, and we want to find the x-intercepts for the following three graphs. Each one of these graphs is a quadratic relationship. We know that because each one of them happens to have a parabola. And so if we look here at the example on the left-hand side, the parabola starts up at the top, it opens up, it dips down below the x-axis, and then comes back up. So it actually intercepts the x-axis at 2 points. It intersects the x-axis, intercepts the x-axis at both point positive 2 and at point positive 6. Okay? So you'll notice that I didn't say that it intercepts at point positive 2 or point positive 6. It intercepts at both of them at the same time. Okay, so there are two intercepts for this point. Okay. In the middle example here, we have a parabola that is opening downward. It gradually moves its way from left to right. It moves its way up toward the x-axis all the way until it just touches the x-axis here at positive 4, and then heads back down. So in this instance, the only x-axis, only 0 is happening at positive 4. Okay, there's only one specific point where that parabola intercepts with the x-axis. And the last example here on the right-hand side, we'll notice that the parabola is opening up, and from the left to the right, it's going down, 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 down. It hits its vertex right here, okay, at about point positive 1, and then it turns. It goes back up. So you'll notice that the parabola on the right actually never does get to the x-axis, which means that there are no zeros. So the number of x-intercepts for that particular parabola on the right-hand side is none. Okay, and so we can see from this graph, or from these three graphs rather, that there's really three different scenarios under which you can have quote-unquote an x-intercept. You can have either two x-intercepts, you could have one x-intercept, as we have in the middle, or it's entirely possible to have none or nil x-intercepts, where there are no x-intercepts at all, as we've seen in this example here on the right.